You ever walk up to a big industrial machine and just stare at the control panel? All those lights, switches, and weird labels? It can be a little much. Well, today, we're going to pull back the curtain on the physical hardware of a PLC. Think of it as the control panel for an industrial brain. And I promise, by the end of this, you'll know exactly what all those buttons and lights are trying to tell you. So here we are, standing in front of this box. This is the brain, right? The heart of the whole operation. But how do you actually talk to it? How do you tell it when to run, when to stop, or maybe even when to forget everything it's ever learned? That's what we're about to find out. Let's take a hands-on tour of its physical interface. First up, probably the most powerful thing on the whole device, the mode selector switch. And trust me, this isn't just any switch. This is the master control. It decides the PLC's entire state of being. Is it awake and running the show, or is it basically in a deep sleep, just waiting for you to tell it what to do? Okay, so it really boils down to two main modes. When it's in run mode, the PLC is alive and kicking. It's actively executing its program, it's scanning inputs, making decisions in milliseconds, and firing off outputs. But flick that switch over to stop, and bam! Everything just freezes. The program stops dead in its tracks. It's like hitting the ultimate pause button on an entire industrial process. But what if you need to do more than just pause? What if you need a complete factory reset? This is where you have to be really careful. Erasing a program that's running a production line could bring a multi-million-dollar operation to a dead stop. We're talking about a massive loss of time, money, and product. And that's exactly why the manufacturers have made this a very deliberate, kind of tricky process. Yeah, to make sure you don't accidentally wipe everything, there's this specific, kind of like a secret handshake you have to perform for what's called a memory reset, or MREs. You'd do this if you were starting fresh with a machine or clearing out a bad program. It's a three-step dance. First, you turn the switch to MRS, and you hold it there until the stop light starts blinking slowly. Second, you pop it back to stop just for a second. And finally, turn it back to MRS and hold it again. This time, you'll see a rapid blink. That's your signal, memory wiped, clean slate. It's designed to be a process you can't just stumble into. All right, so we know how to talk to the PLC, but how does it talk back to us? Well, besides the switch, it has these status LEDs. The best way to think about these little lights is as the PLC's vital signs. It's a super quick dashboard that gives you an instant read on its health and what it's doing right now. Let's run through the big ones you'll see. The SF light. It's usually red, and red means stop, right? That stands for system fault. It could be a loose wire, a programming bug, anything. The DC5V light is your green light, your all systems go signal. It just confirms the internal brain has good, stable power. And the FRCE light? Now this one's interesting. It's your clue that a programmer is in the driver's seat, manually forcing an input or an output to do something for a test. If that light's on, the PLC isn't running on autopilot. Okay, let's talk about something absolutely crucial. Power. How do you even wake this thing up? You can't just plug it into any old socket. You know those seemingly random letters and numbers on the front of a PLC? Well, that's not gibberish. It's a code, a cheat sheet that tells you everything you need to know about what it eats for breakfast. You'll often see a model number that looks something like this, DC/DC/DC. And you're probably thinking, okay, I get it, it's DC. But hold on, each one of those means something totally different. Let's crack the code. So that first DC, that's all about the brain, the CPU. It tells you that the processor itself needs a DC voltage supply, typically 24 volts DC. Just to turn on and start thinking. Next up, the PLC's senses. The second DC is for the inputs. This means it's expecting to hear DC signals from all the buttons and sensors out there in the real world. And finally, that third DC is for its muscles, its actions, the outputs. This tells you it's going to send out a DC signal to make things happen, like turning on a light or activating a valve. So, DC brain, DC senses, DC muscles. See? Makes perfect sense. Okay, but what happens when you see something like this? AC/DC/relay. Whoa, what does that even mean? Well, this is where PLCs get really, really flexible and powerful. Let's break this one down too. All right, let's decode it. That AC at the beginning, it means this PLC's brain can run on standard AC power. You know, the stuff from a regular wall outlet. Super convenient. The DC in the middle, its senses, the inputs, are still listening for those same DC signals. But that relay at the end, oh, that is a total game changer. It means the outputs are just simple switches. Okay, so we've got the power figured out. We can read its vital signs. Now it's time to actually hook this thing up to the real world. And all of that happens through its terminals for inputs and outputs, or what everyone just calls I/O.
It's really simple when you think about it. Inputs are its senses. They are how the PLC gathers information. A button got pushed. A box is in position. Outputs, those are its actions, its muscles. This is how it actually does things. Turn on that motor. Light up that green light. And that brings us right back to why that relay output is so cool. A relay is basically just a switch, a simple on-off switch that the PLC's program can flip. And here's the genius part. Because it's just a switch, it can control a device that's running on a totally different power source. So your little 24-volt DC PLC can turn on a huge 220-volt AC motor, no problem. That separation, that electrical isolation, that's what makes these things the absolute kings of industrial control.
All right, that was a ton of information about the physical side of the PLC. So let's boil it all down into a super quick start guide you can use the next time you're face-to-face with one of these brains in a box. So here it is, your 4-step hardware check. Number 1, check the mode switch. Is it set to run or stop? Super important. Number 2, read the status lights. Is everything okay or is there a fault? Number 3, decode the model number. Make absolutely sure you're giving it the right kind of juice. And number 4, double check your wiring. Make sure your senses and muscles are connected to the right places. So, the hardware isn't a black box anymore. You know how to power it up, you know how to read its signals, and you know how to set its basic mode. The control panel is all yours. But that leaves us with one huge question. Now that the brain is on, what language does it actually speak?